Hi everyone! In this video, I will explain the round-robin CPU scheduling algorithm. So, what is round-robin? The round-robin is a preemptive scheduling algorithm commonly used in time-sharing operating systems. It works by giving each process a small, fixed amount of CPU time called the time quantum, and then switching to the next process. In round-robin scheduling, all processes are placed in a ready queue, and each process gets the CPU for a fixed time called the time quantum. If the process finishes before the time quantum ends, it leaves the CPU. And if it does not finish, it is preempted and moved to the back of the ready queue to wait for its next turn. Our important terms to remember are the arrival time, which is the when the process is enters the ready queue, and we have the burst time, which is how long the process needs the CPU, and we have also the time quantum, which is the maximum CPU time given to a process per turn. Another important role in round-robin scheduling algorithm is that the order of the processes in the ready queue matters. Processes are handled in circular order, which means that once the last process is served, the CPU goes back to the first process again. Round robin also depends heavily on the choice of the time quantum. If the time quantum is too large, the algorithm starts to behave like first come first serve, which can increase waiting time. If the time quantum is too small, the CPU will switch between processes very often, causing too many context switches and wasting CPU time. This balance between fairness and performance is what makes round robin both useful and challenging to configure. To better understand round robin, it helps to visualize the ready queue as a line of processes. After a process uses its time quantum, it moves to the back of the line if it is not yet finished. This movement continues until all processes have completed their burst time. This visual approach makes it easier to follow how the CPU switches between processes. So we have the process time, which is the process is P1, P2, and P3. And we have also the P1 is we have the arrival time is 0 and the burst time is 5. And we have also P2 is 0 and the burst time is 3. And P3 is 0 and the burst time is 1. So all processes arrive at time 0. So now let's schedule them step by step. So P1 runs first for 2 milliseconds and the remaining burst time is 3. The P2 runs next for the 2 milliseconds, remaining burst time is 1. And we have P3 runs for 1 milliseconds and finishes. And P1 runs again for 2 milliseconds, remaining burst time is 1. So we have P2 runs for 1 milliseconds and finishes. And we have P1 runs for the last 1 milliseconds and finishes. As we move to the Gantt chart, notice that no single process is allowed to run continuously for a long time. Each process only runs for a short period before another process gets a chance. This behavior prevents CPU monopolization, where one long process blocks others from running. It also improves response time, especially for shorter processes like P3, which finishes quickly. So the waiting time is P1 is equals to 4 milliseconds, P2 is 5 milliseconds, and P3 is 4 milliseconds. And we have the turnaround time. The P1 is equals to 9 milliseconds, P2 is 8 milliseconds, and P3 is equals to 5 milliseconds. We can also compute the average waiting time and average turnaround time to evaluate performance. The average waiting time is the sum of all waiting times divided by the number of processes. And while the average turnaround time is the sum of all turnaround times divided by the number of processes. These averages help system designers decide whether round robin is performing efficiently under a given workload. A simple way to understand round robin is to compare it to the classroom recitation. Each student gives a short time to speak. If the student does not finish, they must wait until everyone else had a turn. This ensures fairness, but each student is given too little time. The discussion becomes slow due to frequent interruptions. The main advantage of round robin is fairness. Every process gets an equal chance to reuse the CPU, which makes it ideal for multi-user system. However, a major disadvantage is that if a time quantum is too small, the system will have too many context switches, which can reduce performance. Which the round robin is best used in time-sharing operating systems where fast response time is important. In summary, round robin is a preemptive scheduling algorithm that shares CPU time equally among processes using a fixed time quantum. Compared to FCFS, it avoids long waiting times and provides better responsiveness. Thank you for watching. Bye-bye.